you give a brief introduction and like a career progression of yourself so that others can also know.
Yeah, I mean, thanks for inviting me. So I don't have that, that popular career and all. Yeah, I just started, like my career started in, not career, I did my undergrad from from Acharya Nagarjuna University from Andhra in India, and then I got admission in ISC. So I did a master's in microelectronics from ISC Bangalore, and yeah, that's where actually I had that's where actually I actually learned proper, what is core subjects and all.
Mhm.
Before that, it used to be most exam centric. So, and I got, like after my masters, I got into Rambus Semiconductors.
Mm. Yeah.
So, I mean, I worked there for almost like 2 years. Then I moved to, I wanted to do this PhD. So I moved to Germany. In Germany, things are slightly different. I think it's a kind of, it's like there are things like institutes like, research institutes where, it's like 50, like, semi job and semi R&D.
Mhm.
So I joined there to do a very interesting stuff called, integrated photonics. So that means, they had a concept of, integrating a optical device on the silicon, actually, silicon germanium, so that generally if you see, right, the if you see all the data center chips, right, the electronics chip is different and then the
Yeah.
photonics chip is different. So now they both co-packaged actually, mostly in a single package. So the plan is to build uh, a complete chip without having any co-packaging. And I worked there 3 years, but because of some difficulties in the technology, that integration never happened actually. So
Okay.
I didn't feel comfortable. I mean, it's almost like I spent roughly 2.5 years and then I couldn't progress much. I mean, the ICs what I'm building looks working, but the integration didn't work. So we couldn't figure it out, and that is a early invention of those. I mean, those optical devices. So I just looking for a job, and then I moved to UK. And then what happened is all of the sudden, the moment I moved, right, they found an issue in their fab. So within 1 year, actually, they solved the fab issue, and all the chips I designed worked actually. And then so anyway, that's a different story.
Mhm.
And then in 2000, uh, late 2013, I moved to UK. Actually, it's been close to 10 years now. Okay, I mean, just 10 years in UK. So I joined in 2013 late in Infi. It's a very early stage startup actually that time,
Okay.
and they were building. Oh, by the way, I didn't tell what I did in Rambus. Right, in Rambus actually, I used to, like, initial stage, right, so work on kind of mostly ring oscillator based PLLs, and they used to have some fascinated new stuff actually, self bias PLLs, that kind of very interesting. And
So
in
for how
Rambus
long
actually,
were you at Rambus?
roughly 2 years.
Okay. And what prompted you to go for a PhD after being in the
That
industry for 2 years?
so no, basically that's, I mean, since my master's actually I want to do PhD. Okay, like I was more interested in analyzing circuits and all, mostly analyzing, but actually never understood actually what I'm going to gain by doing that. That's where actually, never tried to, like, otherwise I would have continued in ISC,
Hmm.
or I would have done something that time. Like, I mean, one thing what I generally like is, you know like, try, okay, basically my entire masters and then even in undergrad, like, my whole idea is to, try to understand something existing a small piece. I never interested in big circuits actually. Take, like, couple of, single, like, couple of, even some circuits, 4 to 5 transistor circuits actually, try to understand a different way than, what others have been explained actually. And try to use in a very, what do you call, very simple words, yeah, like, in without using much more mathematics and in detailed, like, complicated terms actually. Okay,
Yeah, like
very simple
intuitively.
words. Yeah, little intuitive. Like, I mean, I was inspired by, like Professor Shantipavan and Nagendra Krishnapura. And I think I met Professor Shantipavan in 2006. Actually, he came to IIS once. Uh, he 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 said in a very nice line that influenced me a lot. Actually, it's a modified quote of Einstein that what he told everybody in the group is, if you can't explain in a layman terms to your grandmother, that means you didn't understand. I mean, that's like, take with a
Hmm.
pinch of
Yeah.
salt. So try to, like, that's what actually I wanted to understand actually. So that's why I think, basically, yeah, I mean, my idea is not to innovate something. My idea is to, spend more time in a very, what do you call, a small piece of circuit, and, like, try to understand in a very detailed way. I think that is actually, to be honest, that is how I built my career actually.
Yeah, I actually read some of your papers. Like one was on band gap reference with Professor Rakesh, and
Well, that's yeah, yeah,
they
true.
were also like pretty like the circuits weren't like very complicated circuits, and it was like neat and clean. So I think
Because the problem, I don't understand complicated circuits. That is a problem. I mean, there are, like, very interesting things. Um, like, in my masters, uh, again, I got a chance to, like, our batch in IS is very lucky batch, because we used to get faculty from, cosmic circuits. You heard cosmic circuits?
yeah,
It
yeah,
was
yeah,
like
yeah.
acquired by
Ever,
Cadence.
yeah.
So there actually some analog giants actually. I mean, before Nagendra Krishnapur and Shanti Pavan, there used to a person called PK. He's also, like, I
Oh.
think same roots as Nagendra Krishnapur. Like, he's graduate from IIT Madras, and then somewhere he did a PhD. He is like
Hmm.
very well known person, and he also, like, these people always use the same, like, same kind of intuitive, like, very useful actually. I mean, see, the point is, like, if somebody give a circuit, right? I mean, if you analyze how it works, it's fine actually. You find everywhere, and but that doesn't help you to build something on your own. That doesn't help you to design something on your own, because you do reverse engineering mostly if you analyze, right? Somebody give a circuit, right? So I
Hmm.
think that's what affected, like, in like, if you see, right, the all the IIT Madras recordings, all these things came in 2007, and I was lucky to be as a student that time, 2006 to 2008. I think I feel, that time is very fortunate era. Like, you are in the very initial stage, and then the expectation is a lot lesser because it's
Hmm.
less number of resources, but actually resources are there actually, but is not very well known. But now if you see,
Yeah.
right, you see all over, like, a lot of video lectures, and also you see, like, it's a common platform now, right? So that's, I think, that affected me quite a lot. Yeah, professor coming to Professor Rakesh, that he was my roommate in my master's time. So
Oh. Okay.
we so yeah, he's he I learned a lot from him, to be honest. I mean, yeah, I think, the one thing that is how actually I got interested in, wanted to pursue higher studies. I think one more thing is, yeah, if you have a tough staff in your campus, that's also, like, motivate us to do some kind of research. Um, uh, I think one more thing could be, you know, I think, lot many people, the moment, I'm not saying, something is wrong in these books, but, like, one book affected me is, Professor Thomas Lee book actually, RFIC. Very less people, most other people thinks it's a very specific to RFIC, but actually it's one of the best book for the, one of the best book for the analog. There are few chapters, they're really good. I mean, they are very thought provoking, and you really, I mean, you really have to come up with something while solving his exercise and all. I mean, I would generally recommend,
Okay. Okay.
uh, that affects people a lot actually. I mean, I met a couple of people in my workplace and all. Very few people said, yeah, we read Thomas Lee. Like, the moment I said Thomas, it's advanced RFIC. Yeah, but it's advanced RFIC. But there are few chapters which are dedicated to the basic analog engineering actually.
Okay.
So
Okay.
there are so many things actually, we, which I mean, luckily somebody told me that Thomas Lee book is nice, and then
Okay,
yeah, I think several
got it.
several things motivated me. Um,
So
but yeah,
one
I think
common,
yeah,
yeah, go ahead. Sorry.
yeah, go on. Yeah, sorry, I interrupted. Go on.
So I also was motivated to pursue a PhD, and then one doubt that I had was, uh, is it, let's say I want to eventually get into the industry and not academia, and let's say I want to, excel technically, publish papers, all that. So is it like beneficial to go for a PhD and then join industry? Let's say that the
Yeah,
PhD takes about 5 years versus if I join after a master's and then, spend those 4 or 5 years in the industry and then, rise up.
well, I think it depends on what you want at the end. Actually, I think both are same. I have seen two different variety of people. Like I worked with PhDs who are not very good in basics and not very good in designs. I worked with few people. They are just undergrads here, here in UK, and then I even in India also I met few people. They are just under only graduation. Again, maybe like it's a maybe good college, but what I mean to say is I have seen the only people who did only be bachelors and then did really well, and PhDs they didn't do really well. I'm not, don't take that as wrong.
Yeah, yeah, I
Like
got
I
it.
can tell extreme people, you can Google currently, he's a director of Apple. His name Jarrad Jarbi. He was a principal engineer in 2018 Rambus. He is one of the intellectual guy. I met only once actually. I just met once for 10 minutes. So whenever he give a talk, he used to say, "Yeah, like it's very funnily, just to motivate people. I only had bachelors, but I guide PhD students and I read papers and I helped more than 10 students to graduate from their PhD." That's what he used to say.
Got it.
So I think degree has nothing to do. There are so many people, I don't want to name them. There are so many people who are really good. Luckily, I was fortunate, like I was very fortunate that I was surrounded by all these combinations actually. So I could pick the, best part out of it.
Okay,
So there are
okay.
so many people I have seen. So eventually, if somebody want to settle in job, I again, it's my perspective. I would suggest them to be good in fundamentals and then start their career as soon as they can. Okay. I think if you want to settle in industry, means probably you want to reach a high states in the good level in the industry, or maybe high earning, all those things, right? The degree may not be able to help them, but uh, I mean, yeah, there is nothing, I think
Got
at
it.
the end,
Got
right?
it.
It won't stop.
And
It
does
won't
the
stop
same
anyone.
thing hold for masters as well? Because uh, someone
Yes,
told me
I
that,
think so.
okay, 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 got it.
For example, right? If somebody is, again, it depends on what kind of resources you have, right? I think resources are very important, right?
Mm,
For example, think about I graduated from a college called Bapat Engineering College, which is like, you know, not one of the top college. So for example, if somebody, I know few people in that campus who wanted to settle in core jobs, but they couldn't find it. I think
mm,
getting into the industry, especially in analog, maybe for example, if you take the digital, I think some other fields, there are some kind of industry uplifting programs. Okay,
yeah,
like for example, if somebody wanted to join, they can learn verification outside for six
yeah,
months
that's true.
and then they can. So basically, as long as you have an interest and you have a platform to transfer from transfer you from college to a
Yeah,
decent company. I think that should be good enough. So you need two actually. One is you should be motivated and you should be really good. I think masters also. I'm not saying masters is bad. Okay, my point is it. I mean, in my case, right, master helped me a lot. So from my perspective, like I have a couple of students all over. Like I know few people. I guide a couple of people now. So I keep telling that like degree is something important. So that what will happen is one thing. What my personal opinion is, if you work in uni, So you get to see so many things with less risk. Like if you want to try out a circuit in masters, like there are some colleges, like I think IIT Madras or IIT Kanpur, IISc, they get to like they can put that idea in silicon now actually, not into
Yeah.
in my time, 2006 to 2008. So for example, in industry, I don't think you can try it out. Okay.
Mm.
So I mean, here it's a different, there it's a different. So one thing is it's a less risky place to try out, so many things. Of course, it's function of subject to the, how much, funding you have and all.
Yeah. Yeah.
So I definitely recommend masters if they are not in a, very strong need of job at that moment. So, and also, right, one more thing is, uh, while doing masters, right? I mean, if you like, I think these days in India, several people are, there is a cutoff for masters passage. You need to publish something. So if you want
Mm.
to publish, right, like a lot of people see publication as a, what do you call advertisement. But the actual thing, what will happen in the publication is, I mean, publication is not advertisement. I mean to say that the publication is something, you put it like, finally it'll accepted, it'll be in the Google. But my point is, the main part of publication is not what you write actually, no, what you read to write that. That is something that is a byproduct, the it's a
Mm.
in it's like, pole zero cancellation actually. It's like, it cancels, so you don't see that outside. Okay.
Uh,
um, because you have to read a lot of literature, right?
mm. Yeah. Yeah.
And while reading literature, actually, while reading literature, you learn a lot actually. And sometimes you think that you realize that, there is no need for you to publish the, a concept what you have in a paper. Okay. Just because what will happen is somebody would have done, but there maybe some people are not very popular. Okay. So it won't, it won't come into the picture. And second thing is presenting your idea in a sellable way. I mean, again, it's not selling, like, it should
Yeah.
attract
Yeah. Yeah.
somebody. So you need to come up with, you need to come up with a nice way of explanation to just for the sake of audience to understand. You see my point?
Yeah. Yeah.
As a person who you come up with that idea, you know how it works most probably, right?
Mm.
But to tell others, you need to name something, and you need to, what do you call, segment that circuit into several sections, and then like
Yeah.
you complicate little bit so that it makes sense for others, right? So these are the what do you call, what do you call hidden benefits of publishing something. Okay.
Mm.
There are direct benefits, like maybe, somebody will read your paper and they call you for a job. That could be the, very rare case, but that will happen. Okay. And one more thing is, if somebody can publish a journal, okay, what will happen is, then, your paper will go to the 3 to 4 experts. They're real experts. I mean,
Mm.
again, these are the, like, is correct up to some extent. Like there are some reviewers are like which are like really mad. So I'm not talking about those people. But generally what will happen is reviewers will really give a, hard time. They try the I review few papers. The reviewer's perspective is the following, you know, not that how they are accepted, in which way I can reject this paper. I mean, that is the motto. And that is actually, I mean, you have to be in that mode, not to
Mm.
reject, but like so that you will be very, very
Critical.
hard on the reviews. So what will happen is to explain to satisfy the reviewers, you have to understand that in a very different level actually. Okay, I mean, I experienced it personally. So, like couple of things in my career, I understood really while explaining to the reviewers. Okay, and
Mm.
I had a different perspective. For example, I mean, I haven't published a lot to be honest. Okay, I just
No,
did few
that's not
for
true. I've
graduate.
seen you published a lot of papers.
Yeah, for example, the best thing, what I have seen is I had a one mixed mode band gap for my PhD, and I used a different way of biasing. By the way, I'm a great fan of, like, okay, this I'll come to this point. Okay, I want to tell this point to you, but let me finish this. So we explained the way I biased it. It's one of I never thought that will be the, my whole idea is people understand this band gap nicely and they accept it paper. But
Mm.
actually they didn't find that is interesting. That is a fun part of it. Okay. The fun part is I biased in different way. Everybody's talking about that. And I never realized that is that it's called self bias. Is that important?
Yeah,
Then yeah,
I read that paper.
it makes sense, but like my perspective is different. And then it was in the review for almost 8 months. So the more time it is in the review, right, the more people come and ask you. Okay. So what happened is one reviewer asked me, how this will work. I tried to explain. While explaining, he told me that, right, the gain might be more, can you send the gain plots? I never thought about simulating that. Okay, inner operation. Then
Mm-hmm.
to satisfy, you know what, you have to satisfy the reviewer. Okay, that is the only one way. You cannot say that why do you need? You cannot ask that. So I simulated. Then actually, I really understood actually mm, there is a very strong innovation behind that. I didn't know that until that day. So 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 basically I wrote something in the paper. The final version is only 50% of what my understanding, and 50% is completely the reviewers. The actual reviewers, right? Sometimes they be like a very hard guides actually. You understood?
Yeah, I got
So
it.
your percept will be, I mean, as I said, right, if you see somebody who published so many journals, then they will experience this. But for a couple of papers I experienced this, so I can imagine, right, how hard. I only had TCAS2 and some micro journals. I don't, I mean, if I believe, for JSS and all, it's even harder. Okay.
Yeah,
I mean, I haven't experienced, so I'm not the right guy to tell, but few things I can suggest. Okay. And one more thing is, again, I had so many rejections as well. So I try to, you know, since my master's time, my friend, and he's also one of my guide actually, that Rakesh, Professor Rakesh from IIT Delhi.
mm.
We both used to discuss, some stuff in the college which were not very well explained. One fascinated thing is that, frequency compensation or Miller compensation, which
Yeah,
I believe till now also nobody has understood properly. Okay, there are two cases. One case is very popular everywhere, they explain in IIT Madras and then in textbooks everywhere. The one scenario is clear, but there is a second case actually which is very complicated, which nobody has explained. Okay, so I think it's that journey. Me and Rakesh, right? We started in 2007. Started thinking, and one day, I think he got a major idea, and I just helped him, to be honest. And we resolved that actually in 2009, I guess. And we thought of, how to this one way actually. If you think you have something really good idea, but you don't have, many people, you are not surrounded by that kind of interesting people, then it's better to, if
is
you
it the one
it's
where
not.
you put a resistor?
No, 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 no. No, I'm not saying you change the circuit. What I'm trying to tell is, which I'm planning to, this I wanted to explain in YouTube sometime, but I'm not getting that much time. So for example, right, I don't want to get into, too much technical now.
Technical.
So the idea is, if you take a Miller compensation, right, many people start the analysis with the op amp output pole is dominant, and the op amp, the second pole is non-dominant. Then
Mm-hmm.
it pushes. But there's another case actually. Think other way. What if the output pole dominant and inner pole non-dominant, but still it pushes? But the argument what we have, the way people explain, I'm not saying that is wrong. That is very clear that it will actually show that they're approaching. Okay.
Mm.
But according to root locus, no one will approach. It's always at rejecting only. Okay. So I think, I spent, significant amount of time in my my life actually to understand that. Um, you need to read, one more saying from Professor Yanis Sividis. He says that, you know all models are approximate, but few are useful. You should remember that few. So basically that, the Miller amplification cap, these all are models. So they are, when you learn something, there has to be an assumption behind that actually, and most of the time we forget that assumption. Okay,
Right,
and
right.
99% you don't need that assumption. There is 1% time you need that assumption. Okay, so uh, I think anyway, I dragged this to somewhere to somewhere. So the point is, I mean, so anyway, that Miller we try to explain to the some reviewers, and it was not, the reviews are not in our favor. It's just because, again, this is the way that we couldn't explain our idea in a layman terms. Okay, that's why it was rejected, and after that we never focused. But still, that is a, I feel, still that is something which is worthy of, try and explain to the world. Actually, it's not the, again, if somebody, like people like Professor Shantipan and all, if they wanted to, like, I mean, it's like, it's a so hard topic. It's like, you bury a big mountain and then finally you catch a rat. So like,
Mm.
I mean,
Got it.
it's happening. I mean, like, there are very few people wanted to understand, but no need to understand. I mean, there are so many other important, if you have, much more
Applications.
important things, right? So, like, there is no need to try to understand. But I spent really good time on that. And yeah, one, hopefully one fine day, I'll try to do something on that. Yeah, these are, small things attracted me a lot, actually.
Yeah, there
I
was
mean,
another a Miller compensation paper by you where you add a resistor to make the Miller compensation capacitor look bigger.
yeah, that's there actually. But there is a there are some constants in that as well. If your load current is, I mean, if your second stage current is very small, then it won't work. So for class AB and all, it won't work. Okay.
Mm.
I mean, actually, these all are, even actually what I'm saying is, there are like actually simple circuits which we don't have full understanding, to be honest. I mean, like, I'm trying to say a big pool of people, not everybody. Okay.
Mm-hmm.
If
Got
you
it.
see, there is something called beta multiplier. I'm sure you are aware of it,
Yeah,
right?
yeah.
Beta multiplier. That is actually, I haven't seen anybody explain to me in a very nice way, because I spent exactly since 2006. I'm looking at that circuit every day, every day. I mean, even if you take a rough paper in front of me, you see that. Just because none of the people I met so far actually haven't explained that properly. I think I understood very nicely, but that's so difficult for me. One another problem is I can't. I'm not from English background. Like, I studied, my entire, like, up to 10 plus 2 in Telugu local medium,
Oh,
and then I switched to the English only in undergrad, and I'm not that good in English, just manageable English. So for me, writing something what I have in my mind is, it's a two-step process. Okay, converting from my mind Telugu to English, in
mm.
my brain, it's like several, stages. So, right, if you have several stages of an energy conservation, okay, you lose efficiency, right? Each block efficiency is 80. So, so uh, I mean, it's so hard for me to write something, rather than I can speak. So I shared with several people. uh, it was, according to me, it was not understand properly. I mean, it is
Mm.
understood, but maybe nobody has explained in the common platform. That is also one of my dream. Actually, if you see, right, that meta multiplier has several problems. And like, one time, actually, Professor Shantiban explained actually what is his idea, and he come up with a different one, actually. And the way he explained is, I come up with a slightly different beta multiplier, and that became apparent, 10 years back. It was my first patent, actually, a beta multiplier. Okay.
Okay.
So it was very interesting circuit. I mean, it's not very complicated, right? I'm sure you know how many components, right? For two PMOS and two NMOS and one
Mm.
resistor. If you are lucky enough, you add another resistor, another capacitor for compensation. Okay.
Mm.
And you have a startup circuit, like, maybe it had, like, one resistor and one, and yeah, I think maybe three. So it's all of a sudden, right, it will be like, not more than eight transistors, eight components, right? But that is one of the toughest circuit, according to me. Toughest, if you think from the mathematical point of view. Okay.
Mm.
So if somebody is interested, right, if they open the Thomas Lee book, he has an exercise problem. He used the same. He says that he give an example in his problem, and sorry, one of his one exercise problem, and say that, try to think this, without putting an equation. So you should also see that book. Okay.
Yeah, yeah, yeah.
So that
I
that
got
really,
that's one thing I took away from this conversation. I definitely need to read that book.
exactly. Maybe some other day we can chit chat again. I can show, what my interest in books and what
Yeah.
basically I'm not there are very few very good books which should which we should start using from our undergrad. One is Thomas Lee and second is Willie Sampson. So those two are very important. I'm not saying Rajav is wrong or something. Don't take that wrong.
Mm-hmm. Yeah.
My
I
point is
understood.
uh, these are the two which will help you to go somewhere. Okay.
Mm-hmm.
And then, once you go somewhere, and then Raja will help you to build your concepts because
Got it.
Raja is a one book which was written very systematically, but it was written in a little tougher way so that you don't understand day one because it was like very uh you know very elaborated version of maths kind of thing. Okay,
Yeah.
so I think
Got it.
if somebody use those two, I mean, there could be other books as well. Like there are so many hidden things. For example, right, I mean, I'm a learner now as well. I mean, I'll be a learner for my lifelong. So yesterday, I mean, in the place where I work, right, I mean, we have a very good branch in near MIT,
Mm.
Wilmington. So the people who join in ADA, mostly they are like mostly in that branch are from MIT. So there are several innovations happened in MIT long back. I mean, now MIT, I think, little lag behind electronics. They are good in
Mm.
somewhere else. Uh, so have you heard? There is a frequency compensation called slow roll of compensation. Slow roll of
No.
compensation. It was the one of the best compensation people should try. Okay, it's called slow roll
No.
of compensation.
Okay.
Remember that? It's I forgot the professor name. He died recently. He is one of the he had a very what do you call interesting innovations in 1960s. Like they are very good innovations. Don't know why they are not very popular. uh, Definitely you and the young engineers should try out actually.
Yeah. Yeah.
The only one book which I am aware, again I'm not saying nobody ever, which at least maybe everybody might know, but I came to know recently about that compensation. It was really good. It's if people some are interested in frequency compensation, that is something to try out, but I didn't
Okay.
understand fully. That
I'll
was
check it.
mentioned in Thomas Lee. That was mentioned in Thomas Lee, but it was not elaborated in Thomas Lee. But he wrote a statement. If someone is interested in analog, they should try this book. And that book is out of publication now, but it is in Google.
Okay.
Okay.
Okay. I'll look
So
at it. I'll search for
yeah.
the
So
slow roll of compensation.
yeah, it's a free book in Google. But
What's the
actually,
title?
the title I think is if you type slow roll of composition and you see here, and he has like full YouTube videos
Okay.
as well.
Okay.
That professor name, right? Very hard to remember. Yeah. I could see in it. His name is James K. Robert. Okay, James K. Robert. If
Okay.
somebody type free, uh, he has a chapter. He has a YouTube lecture also, but I didn't attend that. I mean, I didn't use that lecture link yet. But see, thing is that I mean, that's far better compensation than many other compensation, which I think it
Okay.
deserves, better attention, not for the sake of that professor, but for the sake of community. That's what I mean to say. Like
Got it.
mostly what we do is we just stick, Miller cap, right?
Mostly, yeah.
Exactly. So I got a chance, luckily, recently I was lucky enough to hire, have you heard Ahuja?
Yeah. Ahuja compensation.
I hired him for 6 months to work on something, and he's retired now, but he kind of once in a while works on something. So he worked with us recently, and yeah, we had a very nice chat about
Oh,
the
I think he was also from IIT Kanpur.
yes,
So,
he bachelor's from IIT Kanpur, and
yeah.
yeah, he's retired now, but once in a while, if his design Yentu pinches him from inside, he come and work for some time and then go back to the hibernate mode, something like that.
Okay.
Yeah, he's also from IIT. Yeah, I came to know that he's from IIT Kanpur recently only. Okay.
Okay.
So yeah, I mean, I again, let's not get too much details, but like there are so many important things, deserve, like these are things actually, these are hidden things. Okay. So I think yeah, they motivated me a lot. I mean, for me, till now, actually, the band gap and biasing is one
Mhm.
of my favorite things.
Yeah,
Okay.
you published a lot on these topics mostly.
Not published. I mean, in 2023, me, Professor Rakesh, me, and then another professor called Shauri Chatterjee, we gave a half a day tutorial in VLS conference. I think it's a half a day. It was the slides are not public, I believe, but I think we understood the band gap while preparing slides for that. To be honest, because we need to prepare some story, right? Like it's a
Yeah,
three
yeah.
hours,
Got it.
engaging people, and if you put Rajav book in front of them, it doesn't make much
Hmm.
more. So, and also one more reason is they are very interesting, and you if you come up with something, you mostly design what you think in your mind on the schematic. For example, if you got an idea in PLL, right? It takes months to do that. Okay, this is so simple, easy to understand, and fast to
Hmm.
run.
Right, right, right.
Not
That's
so
true.
simple, but like simple in nature. Let's not put in not simple in
Yeah, yeah, yeah,
concept.
yeah. I got it.
Okay.
Yeah.
Yeah, I think very few people explain band gap in the way it works actually. Okay. Uh, so yeah, that's that is
Okay.
actually those things actually motivates me a lot.
Okay.
In fact,
And okay, so this,
one more thing.
yeah.
Yeah, go on.
Yeah, yeah,
No,
you
go on,
finish.
go.
No, no, you finish.
On. Like so many things actually we assume, and then there are some assumptions behind it, right? Uh, for example, right, again, you see this, the man, this beta multiplier, right? It had so many shades actually, like uh, there is a nice saying, I forgot who told me this. uh, People, whenever somebody see a current mirror, right, they assume both currents are same actually. Okay, but that's not
Mm-hmm.
true.
Yeah.
Because there is a second version of beta multiplier which doesn't work, that is very popular in interview. Unfortunately, what will happen is, at least in our Indian academia, if there is a question and then if one is working, one is not working, it will circle around the all universities, all companies, right, for interview. So what will happen while circulating, right? Yeah, the the main enthu behind that one will be lost actually. Somebody will find a reason why it is not working, why it is working, and we stick to that. I mean that is how actually I started. So I'm not saying that's wrong, but what will happen is there is second version of beta model which won't work actually. Okay, and uh, la- the main assumption is, if you do like I struggle to teach to some people, if you do math actually they both exactly works in exactly same way. Okay, you should try it out after our talk.
Mm.
Why? See, people say that maths is wrong. No, maths cannot be wrong. But thing is that we use a simple formula uh, before you
Assumption.
start that maths. That
Mm.
assumption is wrong actually. One wrong in this, the non-working version of the beta multiplier is we assume that current mirror currents are same. That is wrong actually. Okay. It took some time for me to understand that, to be honest. Okay. It's not easy to understand. I mean,
Okay.
I was surrounded by very beautiful minded people actually. There are some people who don't accept things in a simple way. Okay. I have a group of people who never, convince with simple things. Maybe that's why actually it became like that. And Mr. Rakesh, Professor Rakesh is one of that kind of hard person. Okay. I would recommend, what I would recommend, if somebody is very much interested, do some analog and then this biasing stuff. He's one of the upcoming professor actually. Yeah,
Yeah, I
I would
wanted
recommend.
to ask you one thing. So, like when we are at university or college, the goal is to publish papers, or we think with that mindset that we have to, the end goal is a paper. But in
Yeah,
industry, the end goal is obviously the project that you're working on,
product.
or
No,
so
product.
then,
Let's put it
yeah, the
product.
product, yeah.
Yeah.
So then how do you, get patents or papers, or make sure you publish well?
This is very, what do you call, controversial topic actually.
Oh,
So,
oh, okay. Okay, we
so
can skip that.
basically, no. I'm not saying in that way. See, uh, see, the main idea behind publication has to be a spirit of explain to the people so that it reaches the wider audience. For example, if I mean, see, for example, right, lot many you take a differential pair, right? Differential pair was invented by someone. What if he didn't publish, right? Of course, he can make a good product. He can sell differential pair, but after, look from the community point of view, publications are for the community. Okay, So it cannot be like, for the sake of advertising yourself. Of course, it has to be some motivation, but it cannot be the entire motivation. Okay. A publication, the idea behind a publication is to help the community so that, somebody will, take your work and try to do better. Right. So that is what citation, right? So they take your idea. So that means if you publish something, it is no longer yours, right? That is the main motivation, right?
Hmm.
If you So for example, when you are in a university, right? So basically, of course, publications is for the graduation. That is, a well-known underlying theory. But if you publish something, somebody will read it and then somebody will improve it. You get to see, right? See, it's like, you are so young, you don't understand this. When you have children and all, when kids are growing, right? You see how they are growing. You want them to do better than you, right? Obviously, right? And
Hmm.
like that, the publication also, it's your idea. And how many years how many years you put it in your brain, and like you have to throw it out so that it takes somebody. If it is really good, somebody will take it and
Refine.
push it forward, and you see, right? Oh, okay, see, I started a small band gap like this. you know Somebody changed something, it's growing, it will improve, right? that
Hmm.
that is the main motivation behind a publication. Okay. But again, you cannot be doing that way, because obviously you need to graduate in, masters mean 2 years, bachelor's means four,
Yeah,
PhD
yeah,
means
yeah.
five, kind of thing. So you need to have that kind of step as well, but this has to be main motto. Somebody has to read it. So that's why if you see a paper, right, see how many times it was cited. Okay. Very rarely important papers will be forgotten, otherwise they will be cited. So that is the intention behind a publication. Okay. And of course, with the motivation of graduation. But thing is that it cannot be for the sake of, count. Okay. Top professors, scientists like Einstein doesn't have so many. Okay. So the impact is important than the, how many.
Quantity.
Okay.
Hmm.
You can even if somebody didn't publish also, that doesn't mean they are you. I mean, that is for the graduation criteria. Okay. Because you just need a criteria. So you just go with the criteria, right? But the point is, for patent is different, right? Patent means protecting your idea, right? According to me, I can see some of my patents are very worthy, some of my patents not worthy. It's about a business call. If somebody think it's very important and there is a value to protect it, they file a patent. Okay. But when you are patenting, the push from other people is very less. If your company is interested, right, you can protect it. Okay. Simple ideas also. I mean, dumb ideas, I think companies don't allow. But what I'm saying is, I think according to me, publications are something which people read, and they will progress over the time. The
Hmm.
patents are protecting. If you patent something, means you are telling that, don't use that idea. It's mine. So I think I would say it is in that way. Okay. But again, don't be in that, what do you call it? I know people, some people who helped me in my early career don't have any single patent, but they are far better than me. Okay. I have so many, but that doesn't mean I'm good.
Hmm.
The patent is something, I don't know how to explain correctly, but maybe sometime later. It's If you think, if your company think they need to protect it, then it will be a patent. Okay. Protected has nothing to do with the usefulness to the other community, and it might be useful in your case, but may not be useful for some cases. Okay. So I would say, I mean, just to answer your question, how people come up with idea. If you
Yeah.
sit and try to, okay, I need to invent something, we'll never invent anything. So the whole idea is the publications and patents are byproducts. We have a task, we need to do it. Let's do it. If you go in that way, I think either patent or publication or money, all these things will come with you.
Okay.
So I'm pretty sure. I mean, I still remember actually. We are trying to bias a very, what do you call, very complicated circuit, and none of the techniques are working. Then actually we are trying to see, what can fit here. Then I come up with this idea. But if you wanted to, if you want to invent something and for the sake of filing
Inventing.
a patent or publishing, right? Then I
Got it.
think the chances might be less. But again, see, I think you should talk with somebody who has more publications, more patents and all. But that's my idea. Okay,
Got it.
if
Got
you
it.
see, basically, if you find a solution that will turn out to be a patent or publication. Okay,
Yeah, it makes
so
sense. I got
so
it.
for example, right, one more thing is, I long back means it's in the story in 2016. I had a nice idea on a PLA charge pump, but just to put it in simple words, is a current source. So, we are trying to make a less than 1 microamp current source. Okay, first of all, most other people doesn't need it. One thing is maybe very few people, very few companies need that particular current source. Okay,
Mm.
so that means if you see some intellectual person who is in a company where he is always working with 1 milliamp, he don't need this problem. Sorry, he don't need to solve this problem, right? Point
Yeah.
number one. Number two is we are just marginally banging between the existing circuit and trying to find something. So it's almost the present one is working but not robustly. So, but if I have a what do you call it, a little not that tough manager, maybe I would have used the existing one. But actually, he insisted us to improve the result. So he took up to the one of the extreme. So then in that extreme, right, we have to come up with something, and we eventually did a slightly different and non-conventional. So and it became a very what do you call it? It was a part of uh, so many valuable products which are mostly in the big companies in Facebook and all in their data centers now. Okay, but I mean I'm just giving an example. So see, that became a I think me and my colleague. I have a colleague called Simon. He's the one actually who I am today. Like ever since I came to UK, he helped me in my career. His name Simon. He had a
Okay.
only bachelor's degree, by the way, only bachelor's degree.
Mm.
But he invented so many modern circuits. Now he retired, by the way. So anyway, my point is, we if had we are in a different business, and if we don't need that much very low current, or if manager is not that picky on the spec, like if you want less than 1%, he wanted to see 0.99, that kind of nature. So these two things made us to come up with that idea.
Okay.
And if I'm not mistaken, I think the company where I worked previously, I think they filed, I think, 2 patents, I guess. Okay. See, so that's the, you know, that
So
is
that's where
actually
the
something.
manager's role comes in.
Well, there are two kind of managers, by the way. One is, someone who help you to, come up with the best by pressurizing you. But, there must be a limit at some point. You cannot, press someone until, what do you call
You squeeze
See,
them out.
see for everything, right? There is something called dynamic range, right? You see, right? So there
Mm.
is one range. So if you take any circuit, it won't work from 0 to VD, right? There is a dynamic range, right? The
Mm.
lower end noise, top and maybe some linearity, something. So
Mm.
the managers also should see, you cannot, like there is a theoretical limit everywhere, right? So I mean, but the manager role has to push in such a way that, right, we get the best out of many things. Okay, not everything, let's put it like that. But you can't do see at the end, right? You have 24 hours. Out of 24 hours, this is a see one more thing is the analog design has to be a minor part of your life. It can't be major. Okay, that is one thing which I learned. See, you have 8 hours to work, right? And maybe 10 hours if you're really young, and then
Mm.
so I mean there is a limit. Beyond that you can't do anything. Okay, but that doesn't mean that is a stop point. But beyond that, I mean, it depends on how much time you have, how much effort you have. Okay, and I think it really depends on. It's a combination of with whom you work and then how you want it to work. Okay,
Mm.
but yeah, I think just to answer your question initially, right? You asked, right? In industry, publication. I think in industry, publications are very less value. In universities, are publication are main. That is the main source of income for the universities, right? I mean, they need to bring money. You know what? This is the best thing out of Indian universities. In Indian universities, professors doesn't need to worry about the money because the government will pay the money, right? Money means not their salary. Don't take
Yeah,
it.
yeah,
The
yeah.
funding for the projects, they get like minimum from the what do you call, minimum from the
University
government.
grants and yeah.
So university grants. Whereas if you go to the in the US and all, the grants are very less. You go and show off, like you have to present something to DARPA, several institutes, right? So many organizations.
Mm-hmm.
Because I'm familiar with the German system. Here in UK, funding is very tough. In Germany and all, you need to write proposals, go there, and you get. So thing is that it's like this. So in India, you don't get so much, but you get the minimum is more than enough to kickstart a professor,
Okay,
and then I
okay.
think. Okay. But in European countries and all, the minimum is zero. But once you work hard, you get more actually. So other
Mm.
end, it's good. That's why if you see, the European universities can afford, initially they can't afford, but finally they afford, many students. And they are all keeping, roaming around conference and all, they
Yeah,
publish
yeah,
small
yeah.
idea and go to America and then do that. I think it's a little tough in India, but like the initial starting point is quite good there. Yeah, that's
Okay.
how I think that's why I think in item address and all they get to do a lot of chips. Okay, I think even in Kanpur it's starting, right.
Hmm.
But I think they can't, if they have 10, 15 students, they can't afford all the student travel and all, right?
Yeah,
But I think in countries like Germany and all, they do that. But initially, taking 2, 3 is difficult. That surprised me actually. That's what good thing with the Indian system. They
got it.
take 2, 3 with the government money, and then let them 3 of grow, and then you might easily attract industry, and then get
Mm-hmm.
funding from them. It will help 10 students. But this is surprise me in Germany and all, especially. First two
This,
students don't get funding. So without zero, how do you start it? That's a very
yeah. So another
difficult way of.
question comes to my mind when you spoke about this. So I did my bachelor's at IIT Kanpur, and then I had a decision to make that should I go for a master's abroad or in India. So the main idea for me was that in India I could do it in 1 more year because the coursework and all they were being combined within the 4 years, and the thesis
Yeah,
part I would did in the 1 year. And also financially, it was like I was actually paid for the masters from the government, but if I
yeah.
did it abroad, I would have had to pay a big lump sum amount. So that's one thing. But the main thing is, most of my friends who went abroad, their intention was that they would get a job abroad after their masters. So the sole purpose was like a gateway to, US, UK, wherever.
Exactly, exactly. That's what the same thing I explained in a slightly different language than previously. The initial is tough in outside. The initial part in India is quite good. If you do see, have you applied for a job or companies came to you? I mean, in
Hmm.
campus, right?
Companies came.
So,
Yeah.
exactly. So initially it was so nice, right?
Yeah.
Okay, like with less effort. I mean, of course, you did a lot of effort and went to IIT Kanpur.
Hmm.
You must be one of the top students in India. But in India, generally, what will happen is initial part is very easy. Companies will come and help if you are from a decent college and if you put enough hard work. But in abroad, right, it's not easy. There is no specific, you do your masters and and keep applying companies and then but yeah, eventually you get a job. But initially there is a struggle.
Hmm.
Uh, but it's very expensive, man. I mean, it's like
Yeah.
if you want to go to B schools, like, like a decent school for analog and all, it's so tough. I mean, if somebody wanted to do really good analog work, right? I think they should stay in India or, like, I mean, don't ask me why did you go to UK? I'll tell you why.
Hmm.
Um, Doing masters in India is quite good. For example, if somebody did a masters from a good university, for example, if you do from IIT Kanpur, analog, I think you would have published a paper, or maybe you have a constant that you had to publish a paper to go leave the campus, something like that. There will be a very strong criteria. Okay, and that will be very less in US universities for masters. US university masters are, according to me, is like a big business for US. And of course, you get the best out of it. But getting into the best university, in for example, take IIT Madras or IIT Kanpur IISc, where you have so much of facilities to do excel in your courses. But to go to that kind of level college in US, you have to be. I mean, you are like I think your case is different. You are from Kanpur, so you could have get into top schools easily. But
I
For
understand.
someone
Yeah.
who came from, for someone who came slightly, what do you call, less recognized college. Let's say for me, if I have to go to UC Berkeley, it is almost impossible. I mean, you need to have a good GRE score and all. Finding funding and all not easy. Okay,
Yeah. Yeah.
but there is something easy. For example, if somebody is from IIT Kharagpur, okay, there are three institutes they accept immediately. For example, MIT, they take directly IIT Kharagpur students, and you take UC from where I forgot the university, Ali Hajmiri,
Caltech.
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 That university will
Yeah.
take default IIT Kanpur, Kharagpur. Okay, for example, Professor, if you see Professor Ananta Chandrakrishnan from MIT, half of his
MIT.
students from IIT Kharagpur. Okay, so there are some links actually. I'm not talking about those links.
Yeah.
For example, in IIT Kharagpur, if somebody from IIT Kharagpur masters, they can get a easy PhD from Professor Brahmanota in 20 university.
20.
Okay, because they have I think they have a kind of collaboration program or something. I mean, even if you are from IIT Madras, again you get it from Delft can attract easily. So
Mm-hmm.
I'm not talking about that exceptions, but
Got it.
in general, if somebody wanted to do analog, I think, I mean, if somebody wanted to stay in core, I think they should try to stay in India and do masters and do some work for some time.
Okay.
I think according to me, I cannot tell few things openly here, but I know so many people are regret. I think India is doing a lot better in terms of you know. I think one more
Got it.
thing what I heard is we were unable to match Indian pay in Europe. Okay, let's not discuss too much, but India is one of the India is no longer a less paid
Yeah.
country. It's very well paid actually. Okay, it's actually one of my friend did a good calculation. He shown that that's the best place to get in that pay. Okay, for that expenses.
For
So
the
anyway,
cost of
just to
living, right?
answer exactly, just to summarize what you asked, if somebody wanted to find a job in core and they want to do something, I think they should try. If they can get an admission in some IIT's masters, which is not very difficult. Okay, I think compared to
Yeah. Yeah.
IIT JEE, GATE is relatively easy. Okay,
Mm.
so I mean that is one of my dream actually, because I couldn't, I'm not that good student in my like for my undergrad admission, so that's why I got into. So I have some burning somewhere, and I should at least go to IIT for at least masters. That motivated me to do, like
Mm.
I spent almost 2.5 years to prepare for my gate. So that motivation. So like that, if you have a motivation to do, say, do some work in the core. I'm not saying analog. I mean, since I am from that
Yeah.
digital,
Yeah. Yeah. Yeah.
any computer science, anything, if you want to do slightly better, if you get a look for the university, don't look for the country. Okay,
Okay.
so for example, 99% of my friends who ended up in US are finally settled in some software. Very few, like I have a friend actually who is from Tamu, Texas University. He ended up in analog engineering, but very few people that does that because it's very expensive. I know it's
Mm-hmm.
like worth of 40 plus lakhs
Yeah.
now.
But if like
So
someone has the sole intention of, settling abroad, so what if they do a master's in India and then later they want to migrate abroad? Like, is it possible, or are there
yeah, yeah,
many?
yeah. It's possible. It's for example, I know people
At
again
what level?
at what level? Yeah,
Like, not
see,
for freshers, right?
no, 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 no. No, I'm not talking about freshers. For example, you know, some people who did masters well from IIS or IIT Madras, um, they do well, and then once they do decent work, right, they can easily go actually. But again, it's like if you ask me name 1,000 people, I can't name 1,000. Maybe I'm not aware. But for example, I have seen, 3 or 4 students of Professor Nagendra Krishnapura. They directly offered in
Yeah, yeah,
US.
I've seen it. Yeah.
Okay, what will happen is but thing is that again that's exceptional. But if there are so many people in software industry settled, that's a different, it's a job is according to me is a mafia. Okay, it's like there are like a less talented person go very quickly on top of the ladder. It's like it's a function of so many variables,
Yeah,
but
yeah, yeah.
it's not impossible, but it's not easy journey. Okay, but my point is, for example, see, everybody has to work on their strategy what they wanted to do, but 99% of people it won't work, unfortunately. That is the reason. For example, I have a you know uh, not close relative. a relative in my community. So she wanted to settle in US, but he wanted to do a higher studies, but
Mm.
with zero money. See, these two are in a contradiction, right? Contradiction. So
Yeah,
what
yeah,
she
yeah.
has done is she came to Germany to do a master's, but she know that Germany is not the high paid country in terms of tax. I mean, it's a too much
Mm-hmm.
tax and the less
Yeah.
space. And I mean, her sole idea is not to stay there. Okay, I know that. Okay, but of course, she didn't write in her SOP that intention. But I know that.
Oh, yeah, yeah.
So, so she came for masters, and she did masters over Germany. Worked 2 years, but she really did really well in masters. And she worked on some frequency synthesizers. And then once she had a decent masters, she was able to find a scholarship for PhD in US. So
Mm.
I think the total money she spent for her masters is like less than a lakh, because I think
Okay.
the fees in Germany is quite low. I mean, I would say zero, maybe 250 euros per semester, and then you work, and then like y- um, you do that. And she did it. Okay, and she went to UC San Diego and did did really very good PhD. And now she settled, and I cannot reveal her name. We we
Mm-hmm.
can talk offline. So see her strategy, right? I mean, many people have a strategy,
It's
but
smart.
for
Yeah.
some people it won't work. So basically, her idea is, she cannot, she don't want to spend money. She cannot spend lakhs of rupees. So she found this way, but actually she was not relaxed here. Okay,
Mm.
she was not relaxed, and then she did that. But she is not from top college, that's for sure. Okay, so if somebody wanted to go to US in Engage, I think masters is the best program if they have money. That is
Okay, okay.
always there. But that doesn't mean you settle in the field what you want. But in India, I'm pretty sure if somebody did a master's from IIT Madras, I think they will try to settle in analog. Okay,
Yeah.
and then I know people who went, but that is an exception. Okay, IIT Madras is exception now. It's it's all over the world know about IIT Madras,
Mm-hmm.
so they can go easily. But I think this is where actually I need to be very careful by speaking this. This is where you have the word of publication. If somebody these days people are doing publications for that intention, it's not a wrong intention. So people try to do some publications so that people know that like one of I know one guy, he had a very good paper in ISSA 2021. And his whole idea is, like his plan is, I'll go there and present. Of course, that's one of the best paper in that
Mm.
session. Okay, that somebody I can find it, but he couldn't find it, unfortunately. But he found eventually. See, hard work, right? Eventually, in electronics we call steady state, right?
Uh,
That steady state is always works actually. Even unstable system can reach steady state at some time if you are okay. But like immediate is something, that's where actually the
yeah.
point comes. So I think if somebody wanted to go to abroad with less money, I mean, by spending less money, not with less
Mm-hmm.
money, by spending less money, or if they are not, in a position to spend, I think they must do a decent masters in India and work for some time and go there. Um, I think since you are very young man, so you don't understand so many things. I know people. I know people who did really well, but they couldn't settle. Um, for example, in ISC, lot of science students are really good in organic chemistry, physics, and all. Most of the people sole intention is to go for a postdoc in US. That is their. I mean, I'm
Mm.
not saying wrong. That everybody has their own interest. So they come and then they try to work hard to produce so many conference. Their intention is somehow get into a good conference, go there and meet a top-notch professor, talk to him, try to share your ideas. That's very good. Share your ideas and see is there any possibility that you can enter his lab.
Mm.
Okay. For some people in IS, there is a professor called CNR. I think he must be retired.
Yeah, 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 yeah.
All
I
his
know.
students can go easily because if you say, hello, I am from CNR, they say, welcome, you have a red carpet. Okay. So I know people who did from day one actually like this. Okay. And for some people, actually, it's not a main motto. Okay.
Yeah,
I
yeah.
mean, see, you see all these people, the extreme people around the spectrum. Um, See, I can name so many people to, like when I was in ISC, there is a girl called, Radha. She is doing, uh, some kind of physics and electronics. She was trying to deposit, like her plan is to make a 3D chip. It's in 2008 plan, like,
Yeah,
depositing the transistor on top of metal. Okay, which is
yeah.
not possible. If
Now
we
I
could
think
do
they are
that,
doing it.
yeah. So she did really well. I mean, I never thought she will become that popular. Otherwise, I would have, be friendly with her. So so now actually she is one of the world popular. You can type actually, you can try. She is selected in T35. Okay. Like I think under 35, 35 top women. Okay.
Mm-hmm.
Now she works in Manchester as a professor.
Okay.
Okay. So I I think her dream is to do really well. And she did, I think she's very close to Nobel laureate according to me. Okay.
Okay. Okay.
I don't know how many people know this. There is a better, there is, I think people think Nobel is the best, right? But
Yeah.
there's a one level beyond that, actually. I mean, there are many levels. Okay. Like there is something on nature, actually. For science people, it
Nature.
is very
Yeah. Yeah.
common.
Yeah. Yeah. The
People whose Nobel application rejects, they go to nature. Okay. She had one or two like that. So, I mean, the reason why I'm telling her name is she's really good. I mean, like one of the top notch person in the world, and she didn't, what do you call, she didn't go to US for settlement. I think she went for a postdoc. I don't know all the details. I mean, after my master's in 2008, I only read about her in Google. So had I been predicted that, she will become that popular, I
yeah.
would have make really good contact with her. So I was fortunate enough to meet her one time in airport. Now she's a professor in Manchester. So see, I'm saying it's not her dream. If she wants, she can go today. Okay, she
Yeah.
can
Yeah.
go
Yeah.
now actually. So it
Yeah.
all depends on
Even
the
me
what
personally,
kind
I
of
don't have
intention.
a fascination to go there.
Yeah.
Like, and you just said right, ki India is the place to be. Like, there are things going now.
Well, I mean, it had plus and minus. I mean, the moment I why I'm not saying this very strong. The moment I say that, people ask me why did you go. So that's why I'm not bringing that
Uh-huh.
point, because when people when they make mistakes, they didn't know that they are making mistake, right? Otherwise
Yeah.
they'll do that.
Exactly.
They take a path, and then once they dive deep enough, that they realize that it is wrong, for some people, and then by
Mm-hmm.
the time they realize that it's wrong, right, they can't come back. Okay.
Yeah.
I know so many people in abroad in that situation. Okay. But I can say it's in a free country. We can do wherever we want, and anywhere you want you can do easily these days.
Yeah.
But
That's
I
true.
think it's most happening in India. And I would recommend, even if somebody wanted to settle in US, I would recommend if they can get a very good option to do a master's in maybe. Again, I'm not biased to IITs and all. I'm not from IIT, by the way, so I'm not biased. If they do well in masters, and I think they can excel actually. And then
Okay.
once you
Okay.
do some good work, you can go easily. Okay, that's there.
Okay.
And if you see, right, I don't know if you Google it, there is something called EB1A green card quota.
Yeah.
Okay,
Yeah. Yeah.
most of the Indians are in that queue now. Okay, EB1A is not easy. Of course, one underlying one underlying statement for this is, for other nations except India and China, we don't need EB1. So we need
Oh.
EB1, but actually we are the one actually who are in the top notch. Okay,
Okay. Okay.
so if somebody wanted to go, but again, if somebody settle in software and all, they can't do that. I mean, it's just because I think less number of scope for the innovations in. See, for example, if somebody is working for R&D software like Amazon and all, they do a lot of work, good work, right? They develop algorithms and all. But
Mm-hmm.
if they support something, again, I'm not criticizing a typical software engineer. Even in analog also, if you keep porting from previous technology, if you keep, what do you call it, doing the same for next
Yeah.
10 years, that's according to me, it's not, it doesn't take you anywhere. But
Yeah.
you may be a good designer. Okay. So, but if just to answer your question, if somebody wanted to go to US very, like in a proud way, I think like they should do a decent masters and do some good work, and then keep in the, some what do you call it, some R&D work. I think
Got it.
they can
Got it.
easily go. Yeah, yeah.
Eh,
I know
by the
one guy
way,
who
it's
worked in TR.
11:30. You told me that you are busy after
No,
11:30. So
no, no,
just
no.
to
I'm
keep.
not busy. I'm saying I try to do these kind of things. before sun comes here. But I'm not
Oh,
busy. We can go a little bit. I think I have a uh, 15-month son. He will wake up
okay.
at 12 o'clock. So that's why I give 1 hour God band. But yeah, I'm not. But we can continue. So we can do a little more, technical next time if you want.
Yeah,
But
yeah,
yeah, my whole point is, people should, try to follow some good books apart from, I think,
yeah.
apart
Thomas
from
Lee, and
exact.
I took
And
a
also
couple of
one
things.
more, yeah. One more good thing is one more not good thing. One more important, interesting practice is to solve something. Like I know people who listen to the like because I take couple of students in every year. I see
Mm-hmm.
everybody come listen to this Professor Nagendra Krishnan lectures, and they think that will help you to start. Actually, it's like it will get you the escape velocity, but still you need to do something. So problem solving, that is very
Mm.
important actually. Okay, so like that, if you solve something, yeah, I mean, as you said, right? If somebody solved Thomas Lee, I think so
Yeah.
they can be another Thomas Lee.
Yeah. So
Right.
then there was one more. You worked on high-speed SerDes systems, right?
Yeah,
So
yeah.
when I try to read about that, it's mostly from papers and all because there are not many open resources which I could find. So do you have any suggestions for that too?
Well, there are two good open platforms to learn this. One is the very few people, very initial generation people who worked on SerDes is Professor Nagendra Krishnapura.
Mm.
In 2003, he worked on PAM for SerDes. PAM
Mm.
for SerDes is popular now, but he worked
Ah,
in that time. Actually, if you see, uh, so he had a course on advanced, what do you call it? It's called broadband communication theory.
yeah, yeah, yeah.
It's a little bit of SerDes, and Google it. In YouTube, you see EE290C, Elephant 290 Charlie.
Okay, okay. I see.
From he's another giant actually called an Iladalen. He's one of the
Yeah, yeah, yeah.
very
UC
young.
Berkeley, right?
Yeah, yeah, he Berkeley. He did education from Stanford and education in Berkeley, but he worked in Rambus. Okay,
Oh,
he's very well known for the designing regulates, and he's
mm.
like another Shanti Pawan, Professor Shanti Pawan, and another Nagendra Rashnapura. Anyway, he had a course called E in 290C. You should look at it. But the third is right. See, these are the called applications. See,
Mm.
uh, nobody can teach this application online. It just I think see somebody can what do you call give a lecture on analog circuits, but like see that had so many wings, right? I mean, teaching all those wings are difficult, and then
Yeah,
yeah, the SerDes is. I mean, SerDes was new in 2008, but I see it's been almost like 20 years since
yeah, yeah,
SerDes has come. But now actually, um, I think the whole SerDes, right? The whole fun of designing SerDes is gone now because of DSP. DSP killed the analog actually.
oh,
Otherwise, you would have seen because now what they're doing is when I started my career in 2008 and all, there are so see. Fortunately, ADC is there to solve actually. Now what they're doing is you have a big cable, like you have data coming on the cable, and
mm.
then you just amplify the signal. And once you have enough amplitude, put a VGA, make it long, strong enough to trigger a ADC. You are done. That's it. You got an
Yeah,
ADC. Once you have ADC, like typically these days, 6 to 8 bits SR-ADC,
it's
but
that.
high level interleaved ADC, and that's it. Once you have bits right, you know how to play the game, right? Uh,
Mm.
but thing is that actual third is so in this one, right? You don't see too much analogy in I mean, there are still challenges. I'm not saying no.
Yeah.
Like, at this speeds, receiving signal is a lot tougher actually. So
Mm.
people go with recoils and all, and VGA is also difficult to design with high linearity. But like in like 5 6 years back, before DSP is so popular, what you used to do is have a you get a signal and you just receive it and then you boost it by a block called CTLE and
Continuous time equalization.
a continuous time equalizer and then VGA and then we have several equalizers called DFE,
Yeah,
FFE
yeah.
and all. But they are like very interesting to design, interesting and difficult as well. But the problem is, now once you have a DSP, right, they just take the bits and do in the digital. And I just want to tell this, that difference between digital and analog is, in digital everything is possible, okay, but at the cost of high power. You can prove this mathematically also.
Mm.
Everything possible. See, I give two 7-bit numbers, you can multiply, right? It's not impossible.
Yeah,
Just
yeah.
write a RTL code, it multiplies. But the
Mm.
problem, the cost it involves, right? Like, so you do a lot of pipelining, so much of other stuff and all.
Mm-hmm.
It is possible. At the end of the day, a digital designer can do everything and anything, but at the cost of much higher power.
Mm.
An analog engineer can't do multiplication easily. Everything has a problem, right? We
Yeah,
were struggling to do a subtractor in our present project. In digital, subtraction is so easy, but if it is not possible in analog, you have to do it in digital. But if it is possible in analog, that comes with much low power. You can
mm.
even do
Yeah,
some
yeah, yeah.
calculations. It's
On
easy.
a similar note, so there is this debate which people speak that analog is dead, digital is taking over, and like the in the future. So what do you think
Well,
about?
I'm I think you should ask an expert in that. But let me tell you something. Um, I was fortunate enough to learn something from Professor K.R. Karao. Now he's retired. He used to be in TA. Now he retired, I guess.
Mm-hmm.
So he told me one thing. He did his PhD in 1972. So that time he heard the same, that um, I think supply voltages are getting lesser than 7.5. So I think we can't get the required SNR for audio, because those days only audio is the top analog, audio and FM
Yeah,
and
yeah.
sorry, AM and FM and audio. You can't do very good get SNR under 7.5 volt supply. So I think you should think about are you really interested in analog or digital? So then he decided, for some reason, he decided analog. And look at today, we are at like under 1 volt supply, and still we are doing very good audio. So I think in this world, right, there is no end actually. And I don't know how many people know this. Professor Shantipavan actually joined his PhD or master something on device physics. Okay.
Huh.
I don't know why. He
Like
joined in
Yanis
device
Civilis.
physics. No, I think he joined in a different professor. Maybe I'm not very sure. I don't want to give any
Oh,
wrong impression. But he joined on a semiconductor physics or something. Definitely not analog, but he shifted in few months. Okay, I don't know why. So see, and it gave a one of the world giant in analog, isn't it? Okay,
mm,
think about had he been in semiconductor device physics, I think the analog field would have missed so many innovations, right?
mm.
So, or at least they were delayed by a century, right?
Yeah, yeah.
So anyway, back to the topic. So I think the analog will be there, digital will be there. The point is where you draw the line. I think that's important, right? So I think there used to be ADC products long ADC SerDes long back, but now actually, if you take my hand, is this is the the boundary of a RX. The ADC used to be here. It's walking. Hopefully that won't eat away. And again, think about it. See, people are saying digital will take over, right? If digital has to take over, you need an ADC. Don't forget that.
Yeah, yeah.
And people talk about wireless, in wireless software defined radio, and software defined radio itself bring so much of analog complications, though it is software, right?
Mm,
So I
correct.
think my understanding is, I think there is no end for this, at least no, at least you won't see it, I won't see it. We can't forecast what will happen,
Okay,
like
okay. Yeah, yeah, yeah.
so. But coming
Right.
to the SerDes, right, those two are the good platforms, which I believe uh it's correct. And I think there are some other things like Professor what you call Sam Palermo had a very good course in his website. And yeah, I think as you said, right, this SerDes was not very well explained outside. It just because it was probably the reason is it was not easy to build a big SerDes in a university, so that's why nobody taught
Oh,
properly.
right,
But
right.
people people does that. It's a lot more complicated. Okay, it requires a lot of calibration loops and all. So maybe that's why.
Mm.
But yeah, it was not a very well explained outside world. Okay, there is a very good chances if somebody offer a nice course in YouTube.
Yeah.
Ela Dalan has a very good course. Actually, you have to see 290C. Okay,
Okay. Yeah.
it's called. I forgot the course name, but I still remember it's a 290C.
Okay,
It's
okay.
a
Yeah, I'll check it out.
yeah. But again, serial links are not something, not something very something different from analog, right? It just,
Yeah, it's analog.
it's a see in analog, right? Everything analog, we say, is it noise intensive, mismatch intensive, or in a bandwidth intensive? So I think SerDes is something. If we ADC, it's a bandwidth intensive. So getting bandwidth is so difficult. I think it's people are pushing for bandwidth, right? High
Yeah,
bandwidth.
yeah, yeah.
Okay. So, for example, if we take a sigma delta ADC and all, where Professor Shantipan and Agatha Krishna were working, I think it's what do you call noise intensive. And if you take very sensors and all, right, where the touch phones and then temperature sensors, and I think they are mismatch intensive. Okay. So if you are interested, right, have you heard Professor Kofi Makinwa?
Yeah, yeah, Delft.
You should read his articles and all. He
Yeah,
gives
yeah.
this
I
kind of like
follow him.
he's one of the giant actually. He's one of the big giant. He's like, I mean, a lot many people know about him. Most of the people know only Rajavi because of his book. But
No, no.
Makinwa is one of the
Yeah, his papers
is
are also
I don't
nice.
know I don't know how to describe, but he is the one actually who inspired me through his one of the band gap paper. Okay,
Mm,
but he published a lot, so it's very
yeah,
difficult to keep track of
keep up.
keep
Yeah,
yeah, I
that's
think he
true.
has a very funding. And one more thing is we are talking, right? Delft is one of the best university for analog, one of the
Mm.
best analog and RF. Okay, I think, but it's an expensive university by the way, so it cannot be an alternative to
Yeah, but for a
alternative to
PhD,
find.
they will fund it, right? So,
Yeah, they'll definitely fund it for a PhD. Yes,
mm,
yeah, that's there. And I think his criteria is, and if somebody do really well in interview, he will take him. Okay, I know people who worked under him. Um, so yeah, I think
okay, okay,
people should know about Professor Kofi Makinwa.
okay.
I think I'm hoping that one day somebody will list, one of the top notch. I mean, the order, has nothing to do with their abilities. It's just one order. Okay, I
Yeah,
wanted to write something on that, but actually somewhere in the corner, someone come with why he's in the top. So, but unfortunately, when you write a list, right, it has to be top to bottom. So
yeah,
only
you
one
can't do
person.
anything.
So maybe what we had to do diagonal. So say if you do horizontal also, it will be like somebody will or maybe come with a sinusoidal shape and then do something. Like there are very very smart people in this field, but some people are popular, some are not popular. Like I don't
Mm,
know how many people know. There is a person called Robert Bogdan. I can't pronounce his name. It's a Polish name. Robert Bogdan Shkoshkoshki something.
okay.
He's again. You know what? This is one answer to your question. Actually, you asked me in the initially that what if somebody continue in industry, can they publish? He's one
Mm-hmm.
of the good person. Type in Google Robert
Yeah,
Bogdan.
that's what I'm.
He's in UC now,
Okay.
but before that he used to be in Delft. Before that, he actually did only bachelor's from Texas, and then he joined in TI.
Mm,
And in TI, he worked on disk drivers, and then he got some interest, and he did some work, and he did that as a master's in Texas only, okay, while working in TI. And then I think there is a he come up with this in a digital era. So then he what do you call he started working on the digital PLL and all digital. He's a very digital guy, and
mm,
then he come up with a digital and analog, and then he come up with ADPLL, all digital PLL, and that
mm,
became one of the successful product of TI.
yeah,
And he published that as a PhD thesis. And then I think he had, I think, close to 100 patents in that field in those days. I mean, I was
mm,
talking in 2008 to 9 that field.
mm,
And then I think suddenly something pinched him. Maybe I should be a professor. That's it. He moved from TA to Delft.
mm,
And you see his profile now. He's one of the best
yeah, yeah,
in RF. Okay. So see, I mean, I think his intention maybe to be a what do you call it, a nice product developer maybe, but like no, his innovations, right, brought him to the academia now, right?
right.
Of course, he works with so many companies, and I think he had a
Mm-hmm.
startup on quantum computing. And
Mm.
I actually, this is, one regret for me is, in 2011, I applied PhD under him. I just lost in
Oh.
the final round. Okay. So
Mm.
I did well first few rounds, and then he gave a project to work it on and then
Oh.
come up with something. Yeah, he gave a topic of a time to digital converters. He gave a problem, gave a month to think about a solution. I think I gave some garbage solution maybe.
Mm.
Yeah, so he's very nice guy. People should know. In India, actually, people should know about these people. Okay, and this kind of people have very good funding actually. Like they look for a good students,
Yeah.
and yeah, anyhow, we side, we went somewhere to somewhere. So
Yeah, and also related to startups. So you worked in a startup before analog devices, right?
it was a startup. It's called
Oh,
Infi, INPHA. It
yeah,
was a startup, but by the time I joined, it's like
it
decent
grew.
company.
Okay.
But it had several problems, similar kind of startup problems. And yeah, go on. Yeah, you are asking
So
something.
in India, what do you think? Because to start a startup in semiconductors versus let's say software. In software, I believe that you can, you if you have a laptop, you can at least get something working.
Yeah,
But in semiconductors,
yeah,
you have
yeah.
to fabricate and all. You need a lot of resources. So
Exactly. Yeah,
if someone, he has that aim, he wants to start something, how, you know, is it even like, I won't say it's impossible because I don't think it can be doable, but
yeah.
how
It's
is like,
yeah.
what do you think
I
about
don't
that?
I don't have answer. That is the reason I think very few startups came in India and successful in semiconductor. The only startup I could think of is two. One is the
Hmm.
Cosmic Circuits, and if you see their history, right, it had a traces from TA. Okay,
Yeah, yeah,
people from bunch of people from IIT Madras, worked like several years in TA.
yeah.
Once they acquire see, not only money, you need a good engineers, good money, backup, and then you
Connections.
know connections, right?
Mm.
Otherwise, what you will do, right? So I think they had all these three, and then they were brave enough to move out of TA and then started. And also, you need a like-minded people. Also, fortunately,
Yeah,
those
a
four or
team.
five people are very
Mm.
like-minded. And this is from TA. And second company I know is Steradine. That is
Yeah,
also from TA. So
yeah.
so, so it says that if somebody work in TA and then they can do that. So maybe you have that chance. No, just kidding. But yeah, I think
Uh,
as you said, it's not easy to do that, but it's not impossible. And I think I don't think I have a
did you ever feel
I
like,
don't think I can answer. Uh, I think it's the reason is startup is possible. You should have enough time and all. First of all, I mean, see, I don't have time is a wrong answer actually. Okay, what you are
it's
doing with the time
priority.
is important.
Mm.
Exactly. I have other priorities to do that. So my mind never driven me towards that. But I think that's something if you have a good idea, you can try. But seriously, I think in India, getting funding is not easy. So
Mm.
either you have to, uh, I think, rich enough to fund from your pocket, or brave enough to find from outside. But
Mm.
finding from see, you have to rich enough means maybe you need to be lucky. Uh, Otherwise, just a second. So so what they do is most of the time you need to what do you call what I'm saying? Yeah, most of the time I think you need to wait enough time to to build some reputation in the industry and do something. But actually in India, the successful there are I know so many companies who are successful, uh, but they were not successful in the product. Okay, services is in India is one of the best successful place,
Mm.
and I have seen like at least 20-30 companies were very successful.
In
Okay,
circuits.
yeah, circuits. If you see right in IIT, sorry, in Hyderabad, there is an institute called Soctronics, SOC Tronics.
Okay.
So their motto is different. They take undergrads from unprivileged colleges and then they train them. and they find a some connection with some top-notch company, and then like some okay, it's a different what do you call it? It's a different, but the idea is they will find a bridge for you to go from nowhere
Okay.
to a nice place in industry.
It's like a
So
training
they do
institute.
exactly, but
Mm.
I never thought they can train in analog, but they did it actually couple of years back, and they did it, and they were uh, they were successful enough to sell that to Silicon Images, and that's a part of ADA now. So I know these people. So, but again, they started like see, they have no interest to make a product. See,
Mm.
they trained
Yeah.
people, and then they were lucky enough to. I mean, I think in analog that path doesn't work. What do you mean by work, right? You have to define, right?
Yeah.
So if the company the person who started company, if he has a smart enough to sell anyone to anybody, there are people who does that. So I think in analog, if you want to do a services, I think it's possible. But
Mm.
if you want to do really product, that's very difficult. Not impossible, but it's very difficult.
Mm-hmm.
Okay, it's you need to have a real amount of money. See, these the problem right these days. Uh, I mean, the mass cost is one of the biggest problem. Okay,
Mm.
uh, don't know are you aware of or not, but the single digit nanometer technology
Yeah, yeah.
is
EUV, those
is
lithography machines are like billion
yeah,
dollars and all.
it's like I know how much it is.
Um,
So it's not easy to do that. I mean, if you have own fab, right, that's a different. I mean, like for example, TA and I'll encourage people to fabricate their circuits
yeah,
in 90 nanometer. Our Euro practice can do that. Okay. For example, uh, the startup what I'm saying, Steradian, right? They were acquired by Renesas recently.
yeah, yeah.
They again they worked like 20 years in TA, isn't it? And
Mm-hmm.
one of the founder from IIT Kanpur, I don't know whether you heard or not. IIT Kanpur microwave group. By the way, IIT Kanpur is very strong in microwave. Right?
Yeah, yeah.
Uh, One guy from Steradian is a manager in TA. So that is how I heard. I've never worked. One of
Okay.
my best friend here in UK worked in that group. So I know these things from him. But otherwise, it's not easy. Okay, let me put
Mm.
it. I could be wrong, but that is my take. Okay,
Mm.
it's not easy.
Okay.
And one more thing, the EDA is so expensive. EDA,
Huh. Yeah,
that is
licenses for like let's say even cadence and all.
yeah, cadence is like a startup cannot think about a cadence. Okay, forget it.
Mm-hmm.
But actually, you know what? There are some startups in Europe who give a very cheap, what do you call tools for very cheap. Actually,
Oh,
I know one company who literally give the LVS layout tools for like
huh.
few few tens of few tens of the I think 10-20,000 dollars they give. There is a very two people startup I know. It's called TechCDA,
Okay.
TXEDA, which used to be a small village used to be in the small village in Germany, and they did it. One more advantage, in Europe, at least, especially in Europe, I see is there are small fabs, very small, like in-house fabs. They encourage startups actually. There is a
Oh,
fab called IHP. That's where
yeah, yeah.
actually I
Fraunhofer.
did start it. Yeah. So they have a small fab, but it's not expensive. It's 130 nanometer by CMOS and then CMOS. So, if some startup had a sensor idea or something, they can try it out, and they don't charge a lot. Like, I think again, if somebody go with the Euro practice, right, it will be like 10-15,000 euros. Okay. So uh, I think, yeah, my answer is the
Got it.
startup in India, at least in analog, is
Got it.
one
Got it.
extreme end of difficult. That's very close to impossible. Okay.
Mm-hmm.
Uh,
It's like it's impossible until it's done. Once it's done, then you'll get to
exactly.
know.
Yeah.
Okay.
So
Yeah.
yeah,
I guess.
that's my answer. I could be wrong. Okay. I could be wrong, but
Yeah,
that's
yeah.
my
These
take.
things are like
But
it's no black and white answer. Like it's like gray. It can be
absolutely.
anything.
Yeah. But actually, if somebody has that intention, they should, start building. Like I know people who are successful. I'm not successful, and it's not my intention to do that, by the way. So the idea is, since day one, like you at your age, start building connections and try to expose yourself to the outside world. And I think, yeah, I think once you have a decent idea, if you have very good contacts, maybe who knows, right? Somebody from Europe or somebody from US might say, yeah, you know, I'll fund, like they can give a funding, right?
Mm-hmm.
So uh, I think connections might make, it might take major role compared to the idea. I mean,
Right.
if you have connections, I think easily you can find someone who is good in doing something, right?
Mm-hmm.
That's my understanding.
Okay. And so I'll just change the topic now. And in college, like when I appeared for interviews, the questions are like for at fresher level interviews are very basic. So
Yeah,
I wanted to know at senior levels, let's say 3 years, 5 years, maybe even 7, 8 years experience, how do interviews change? Like how do they evolve? Are they still the same
I,
kind of interviews or things are different?
I think that is how I would go. But again, there is a saying actually. Okay, for example, if somebody come with 1 year experience, if somebody come with 10 years experience, let's put it another way. Does he has 10 times 1 year experience, or he has 10 years experience? That's important actually. Or 2 times 5, or you can take. So
Got it.
basically, the idea is right. With experience, what will happen is your knowledge will grow up. So sometimes, right, the industry is a dangerous environment where it can kill one of your problem solving skills sometimes. So if you call a 10 years experience guy and ask him to derive Miller compensation, it's it's not impossible, but he might be little what do you call he might be little uncomfortable. Okay, so maybe I think if you put the idea which generally I take entries in the following way. I try to see, for me, on top of analog, the very good circuit theory is very important. I am great fan of circuit theory actually. Circuit theory using proper theorems. Like theorems is not for the sake of like using in the exam, but like in the real time how to use it. So even for freshers and entry experienced people, the only difference I feel is, like, for fresher, we cannot ask any, very big circuits for a maybe experienced person. We generally see, like again, what he's doing, try to see how he has done. Forget about what he has done. Okay.
Mm.
It's like this, right? It doesn't matter where you are, but it matters only how you are, right? So
Mm.
see how he has done in the last 10 years. Okay. But not at the cost of losing the concepts or something, because see, fundamentals are fundamentals. Electron is always, the electron weight doesn't change, its charge doesn't change, right? So it
Mm.
will be there. That's it, right? Irrespective of how long you work, right? So I think um yeah, I think the problem solving skill has to be there and it has to be checked. uh, and but again, right, you cannot ask very what do you call big derivations and all, but yeah, that's something which a fresher can do easily because he will be very familiar. And I think what you have to see is the one difference what you can notice from a fresher and experienced guy is, ask a fresher and give a Miller compensation and he can derive, but he may not what do you call what do you call he may not grasp something fully. He may not grasp everything from the derivation. Okay, like he got a big equation
Mm. Mm.
and he may not be able to simplify that equation because he may not be familiar with the approximations. But what
Okay.
you have to see is he able to understand the circuit? Okay, maybe he may not be able to design properly. I mean, that's not his fault. I mean, that is how it has to be. Okay, so check his fundamentals for fresher. And again, don't ask, like I have seen people, interview is not something that you show your skills. Check his skills. That is a difference actually. I face this. Okay, I face
Mm.
this. I had a bad experience in tax instrument in 2008. It's bad in terms of different way, not in technical way, but anyway,
Mm.
I ended up in good company, by the way. So what you have to do is check for the how strong he is and is he able to analyze things properly and is he willing to learn. That is important. Okay, even if you don't know anything, if you are willing to learn, that will happen. Okay, provided you are in a good environment.
Mm.
But for experienced person, yeah, you should see actually how he is doing. And if you see, you know, have you heard of Professor Boris Murmann?
Yeah, yeah,
Boris
Stanford.
Murmann. He used to be in Stanford. Now he's in
Yeah.
Hawaii,
Oh,
Hawaii
okay.
University. So recently, a couple of months back. So it's
Uh-huh.
not very old news. So he used to say that spice monkeys, experienced people are spice monkeys. So he has a comic picture. Maybe I'll post you. So there's a monkey, you know, sitting around, and he has a mouse, and then he twists his tail to the mouse and keep playing with the mouse, and then what do you call trying to design something. So there are few people who see, for example, if I give an op amp, if you want to compensate, right, what you do is you can sweep the capacitance, right, from 0 to infinity, and cadence will do that, right? Do 0 to infinity to find a sweet spot in a bubble sort. You go with
Yeah,
binary
yeah, yeah.
search, right? You
Got it,
find
got it.
a fine bond, go there and do that, and you find it, right? So if you do that, it works for one parameter. But what if you have two parameters? Then you have to sweep two. What if you have 10? So that's where actually you need to find an optimal point, right? So that's where actually you should see how an experienced person is doing. So the bottom line is, I think fundamental wise, the both are same. I think fundamentals, I think a fresher might be far better than experienced, but there are some people try to preserve those, things. I mean, at least now, even now also, what I do is, I like deriving things, once in a while. I mean, I do things just because I don't want to lose the, track of it. Okay.
Okay, okay. Mm.
And so I think there is not much difference between fresher and experienced person except for what he has done. Okay. But for example, you take an experienced person, unfortunately, due to, some, I think even our nation is not same. For example, if he hasn't done enough work, what we are expected, that doesn't mean he's like, that doesn't mean you have to look down on him. I think, uh, check, like, is he, is he fit for, for the job, maybe, right? And for example, see, one more thing is carefulness, right? I mean, the fresher may not know all the, all the expensive mistakes in
Mm.
semiconductor. That is not his fault, okay? And but an experienced person should know, see, basically, yeah, product development is not just design an op amp, right?
Mm.
Carefully, see, designing op amp is something, and carefully placing this op amp uh, in a pa- in a part of a big system where somebody should be able to drive you and you should be able to drive. So look
Mm.
both sides. That's what I.
Got
So
it.
he should be able to see that properly, right?
From the
So
broader
that's the
picture.
difference exactly. And carefulness. Like for a product, you need to see so many things. I think concepts innovation is only 10% according to me, because once you invent something, that's it. That's innovation there. But how do you show that to the external world so that it will work, right? Because industry is something you make money finally, right?
Mm.
So so basically, what you have to do is how carefully is, ask some, very fundamental things, how you shut off a block, how you take care, power sequencing. Those things are very important. And
Mm.
I worked with a very nice person called Mike Harwood. He's the one actually who brought me to UK. Okay. He's like got to me. His name Mike
Mm.
Harwood. He was a SMTS in Texas Instruments. Okay.
Oh.
So, because the startup where I worked is a spin-off from Texas Instruments. See, all startups I'm taking from CTA. So anyway, what he used to tell is, if an experienced person design a block, what he has to do is, once you design the block, let's say it has 10 pins, you should see each pin is doing his job or not.
Mm.
Exercise each pin. It's like, we have two hands. How do you know that your two hands are working? See whether both hands are doing its job or not, right? Okay, like that. He used to say you have 10 pins, you should exercise all the pins and see, like, you should know the reason why that pin is doing, is that what it is doing. Not only for you, one pin might be useful for somebody, but that is incorporated in your block, right? So
Mm.
see how you are able to drive somebody, how you are driven by somebody. So
Mm. Both
I think
ways.
this is more important than designing that particular section. On its own, I think people can design nice jobs. Okay. Like, I think after 5, 6 years of experience in analog design, I think people can design an op amp, people can compensate it, show the phase. And that's why in design reviews, I don't look for that, because anyway, people come up with that, right?
Hmm.
It's like the phase margin, gain margin, all the standard stuff is very known. So, but the problem is that have you simulated that phase margin, gain margin, the right condition? That is important.
Um,
I had a
okay.
very.
It's a very good point.
I had several failures actually in the past. Okay, and I always tell to like some of my students and all, if mistakes makes wiser people wiser, I must be very wise person. Okay, that's the standard statement I believe. So, for example, right? See, for example, a person who came from university may not know that in the power up maybe the circuit might oscillate, right? But
Hmm.
experience person see, yeah, I simulated phase margin, gain margin, it all look beautiful. But they all are approximation at the end, right?
Yeah.
The so all models are approximate, but few are useful. So like that, the phase margin, gain margin useful. I can show you some scenarios where phase margin, gain margin fails actually, and there is another margin called vector margin. Okay, but
Oh.
there is no limit for the theory. Okay, there is no
Hmm.
limit for it. That vector margin. Very few people do that. Very few. I just heard and I did only once. But the real proof is it's like this, right? Real proof is put it in circuit and run transient, right? And everybody has to do that. It's called ping test in Europe. I
Yeah.
don't know what
Yeah.
you call it.
Yeah. Ping test.
So yeah, I mean, in India, I never heard that word. I always used to see heard that step response. But anyway,
Yeah.
all are same. But
Yeah.
like we need to do that in the power up, in the power down everything and see. Sometimes right things may oscillate while powering up, and then it won't even reach the point where you are simulating, right?
Yeah. Yeah.
I think these kind of things. I mean, I think this electronics and especially analog is a very dangerous world where so many things could go wrong. So many. Okay, so I think the experience should bring this kind of things into the picture. Actually, he has to bring like um, the more failures he has, more experienced he'll be. Okay,
Right. Got it. Okay. Great. So.
so that's I think yeah, maybe
Understood.
yeah, that is
It's
how I think that is how actually you need to discriminate, not discriminate. That is how you need to distinguish. Sorry, I'm
distinguished.
not that
Yeah.
good in English sometimes.
Yeah. Yeah. Understood.
But yeah, but thing is that some people feel really bad if they give a written test for the 10 years experience, but there is nothing wrong actually. I like I think
You mean someone who's younger than that giving a test? Or I didn't get.
yes.
Oh, okay.
No. What I mean is, if somebody is what do you call if somebody is if somebody are not younger and older, like for some experienced people thinks okay, we cannot take written test. But actually, written test is very interesting, and people should enjoy it. Actually, if
Oh,
somebody
okay.
say no written test means maybe they are not willing, or maybe they have what do you call maybe they are not interested. So according to me, I think they should be ready to
Give a
just
written.
written test, right? See, thing is that written test is not something very. I mean, again, that should be sensible written test. Don't give a third order system and ask him to analyze. That's not. Don't check his
Uh,
mathematical skills. Like check his thinking skills, right? If
mm-hmm.
you want a mathematician, that's a different story. You should advertise that, and I need someone. Uh,
Who can do algebra
luckily,
and
exactly. Luckily, luckily just a second. I need to. Luckily the analog field, right? Give me a second.
oh, hey, this meeting will again, it will end in 1 minute, 30 seconds.
Oh, one
So,
minute 30 seconds.
yeah,
Okay. Yeah, I'm fine now. So basically, I could hear my son voice somewhere in the car. So I just came to.
yeah,
So this
actually, I
meeting is ending.
took,
Maybe we can schedule something later today if you want. We
yeah,
can
yeah,
continue this. Okay.
sure. I anyways took a lot of your time. I mean, I'm very
Okay. That's
grateful
fine.
for
That's fine.
this.
This is the perfect time for me. Maybe next week if you want, we can talk and then we can continue. Okay. Yeah.
Yeah,
Maybe
yeah,
one fine day I'll show you know what books I use. Okay.
yeah. We'll try to sync up like next weekend or whenever you are free.
Yeah. Maybe next Friday. Maybe. Okay.
Yeah,
Yeah.
sure. Okay.
Okay.
Yeah.
Okay then.
Yeah.
Thank you. It was
Thanks a
nice
lot.
talking to you.
Yeah.
Bye.
Bye bye. Bye. Have a good day.